Yeah.
Really cool. Everybody has this warm eye slide. So I was like, I think a cool one would be just to Google my name and see which images pop up. And this is what came up. So there's like a burrito that I ate. There's a bar that I went to. There's another picture of a bar. This is actually like a rowing time that I set, which I'm quite proud of. It's so pathetic though. And there's a whole bunch of pictures. And this is me still installing CyanogenMod on my old phone. Yay, Eugene's proud of me.
I remember that.
Yeah, but yeah, this is the legit real my slide. My name's Keith Makan. I'm a consultant at iActive. I did some bug hunting a couple of years back. I don't really do it now anymore because, well, not public bug hunting because it takes too much energy. You literally got to like sleep for like 1 minute every day. There's literally guys that do this bug bounty thing for a living, and they, for hours and hours, they just like, one guy described this process, and he said like he just presses refresh, waiting for a new bug bounty to show up, because there's an element of competition to like getting to the target before anybody else does, because all the easy bugs will dry up. So you can make thousands of dollars just reporting like clickjacking and like mixed scripting and all the easy stuff that a scanner can pick up, as long as you get there before anybody else. So that's an element of the game as well. I mean, it's such a big like rat race now. Most of the money in it, of course, you can make money being really, really good, but that's really, really hard, and you can't really. You can't be like, oh, go to the bank, like, oh, can I get a home loan? I kind of sometimes make this amount of money. Like, it's not gonna work. But yes, I wrote a book, 2 books. This is obviously before I started playing StarCraft and Elder Scrolls Online. I had so much time, like I banged out 2 books. I like playing Pokemon, and I'm trying to grow a beard full on my life. That guy's way better at it than me, obviously. Like, probably takes beard steroids. Yeah. So yeah, why this topic? First of all, the key reason I want to talk about this is because I like solving this problem. That's when it comes to the bottom of it, that's the only reason. But the other reasons are like it's a good intersection between a classic computer science style of solving problems and an area of applicability in information security. So really, this is just an algorithms talk that is sort of presented in the context of penetration testing. So that's all it really is. And also chick stuff, guys, with fast algorithms. I don't know if you can make can you guys make out this picture? Like that took me a lot of effort to find that one. This is a legit picture actually taken in a club. Yeah. For those of you who don't know, those are names of algorithms that are like pretty efficient, and it's like a guy going, hey, pretty cool, look at all these chicks that like me because of my algorithm.
I said no one ever.
Okay, so I had this conversation with somebody about my talk. No, it's not nobody in this room. It's just some guy that I know, and I'm like, this is what the talk's going to be like, and I wanted to get his perspective on it. And he's like, oh well, like I can see why you would want. I can see what the talk is about. I understand, but it's kind of not going to change day-to-day practice for a penetration tester, which is not true. If you're really open-minded, it will change what you do from day to day. But he kind of started using words like, it's not really applicable, it's purely academic, and I really don't like. I sort of thought about that idea of saying that research is purely academic. And the conclusion I've come to is that there's no such thing as academic research. If you say research, this is just my opinion, you guys can take me on this when I'm done with the talk, but in my opinion, if you say research is purely academic, you're making a statement about yourself and the way you appreciate the research, not about the research. So I mean, one guy could say, hey, I just proved De Fermat's a little theorem, and that might mean like nothing to you, but to a whole bunch of mathematicians, astronomers and physicists, that means like they can use a whole different way to prove theorems that talk about the astrology and the materials of the universe. But to a lot of people, that would just be purely theoretical. Who cares that a to the n plus b to the n equals c to the n? Who cares? You know, it means nothing to me. But you should be very careful about labeling research as purely academic, because you're kind of cordoning off that research to one area of applicability, and that's something that only applies to you. I could still come and take the research and make something practical and useful about it with it, but that depends on your appreciation. Anyway, that's all I wanted to say about that. Oh, cool! I can use the page down. I know it'll be so clean. Here we go. Okay, so I'm not going to make any assumptions about anybody in the room. I'm just going to quickly introduce SQL injection. Basically, it's when you can take input given to a web interface that's interpreted as a SQL query. Usually these scripts build dynamic queries from user input. And obviously that means that you can then inject characters or parts of the language that doesn't mean anything to the web input, but would mean something to the SQL, the thing that evaluates the SQL statement. And that sort of opens up a whole bunch of, it kind of makes the data more active than you would originally see it, because now you can construct arbitrary queries. That's the basis of it. I take it everybody knows what SQL injection is, right? You wouldn't come to this talk and be like, what is this? But yeah, so SQL injection, it's sort of, then you can split it into areas, into different topic areas according to how you extract the information. So everything is the same kind of information extracting, but how you actually interpret and how you extract it, that is the different, that sort of forms the basis of how you classify it. So you get classic injection. This should actually be called classic extraction, blind extraction, time-based extraction. But for some reason, they just decided to stick with injection because of what they're talking about. It's SQL injection. But yes, classic injection is when the results are purely reflected on the page. There's no difficulty to that. You just ask it what it wants, and it shows you all the results you're asking for. No restriction. And, yeah. So then, there's one I forgot here, error-based, but I'll get to that now. Blind injection is just you can ask it true or yes or no questions, and the only result you see is an indication of either a true evaluation of your query or a false evaluation of your query. That's all you get to see in most cases. Time-based is when the output, you can't influence what the output of a web application is, but you can delay the output. So if you guys know anything about databases, you know that, like, I think this is MS SQL. It has like a little function where you can tell it to sleep the database thread a little bit before it responds. So that you can actually use to construct some kind of side channel that you can use to infer information. So let's say you're asking it, is this character that I'm extracting, is it an A? And if it is, sleep for 50 seconds. If it's not, don't sleep. So then you can actually tell from the response, if the response is delayed, that you're extracting an A. And that's kind of like the way you can extract information. There's also, this is probably one of the cooler ones, is out of band. So some databases, systems, they allow you to like look up DNS names, or some of the things they do result in DNS name lookups. And what people do is, because they have control of the local DNS server, or they can see these DNS queries, they extract information using that. So they'll craft a string that's a DNS name, and inside the string there's a payload they're trying to extract. Let's imagine it's like a hash. This is an MD5 hash of a password, and they tell the database, they tell the DBMS to look up that DNS name. And as a result, it like leaks that information through a DNS query, and that you can use that to then extract information. It's very clever. It's also error-based. Really forgot about that. But you trigger errors, and on certain DBMSs, the content of the error can be controlled. So you can tell it to trigger an error on a key, and then it will print out the key that's causing the error. Let's say it's like a grouping key, or it's a type conversion that's gone wrong. It'll print out the key, and you just make sure the key is the payload you're trying to extract, and then it'll actually reflect that. So you can say, please group this little table on the admin hash, and then it will fail, and it will cause a grouping error key, and it'll print out the admin hash to the page. But that's in situations where only the errors are being displayed. And this is a common mistake because people often leave debug checks on. They sometimes want users to tell them what it says on the page so they can sort of triage what's going on. But that can be exploited because most DBMSs will divulge a little too much, or can be caused to divulge a little too much about what's going on. So you can use that to extract information. So that's SQL injection 101. I like this comes from like sort of the physics and maths style of talking about a problem. There's like always a part in the class where the guy says, this is the problem, and we're going to solve it now. And the reason they do that, they have like a sort of a formal statement of the problem, is so that you're not confused as to what your goal is with what you're going to be talking about. So this is the SQL injection problem. If you're trying to extract information and the database only gives you true or false responses. What's the most efficient way to extract information? It's as simple as that, right? So there's a couple of caveats as well. You can use we don't want any solutions that only apply to specific DBMSs or too little DBMSs. You have an unlimited amount of storage space. You have an unlimited amount of time. Obviously, you're not going to use all the space if it's unlimited, but it's just so that you don't really use those constraints. It doesn't hinder your problem-solving process. Why is there a picture of Daredevil? Because he's the most famous blind superhero, I think. And why this version of Daredevil? If there's a new version, because you have to be blind to like that version. That's why. That's like the most terrible. I actually didn't like Daredevil when that came out, and now the new Netflix thing I've been watching it, and it's pretty cool. So now I like Daredevil. But Ben Affleck was definitely a mistake. Yeah. Okay, so we're going to be talking about efficiency, and if you're talking about efficiency, you need some kind of metrics to frame what you're talking about. Because you can't just be like, oh, this is efficient because it gets me more apples when I go to the groceries. When I go to groceries, you have to have terms and numbers to associate to your efficiency. So if we're going to be extracting information, we need to measure information, and usually we measure that in terms of bits. So amount of bits equals amount of information. And then cost. There's a cost to extracting it, and the cost per bit we're going to call a request. So one network request is one cost, and one bit is one piece of information. So then the number you're looking for is bits per request, right? That's the metric we're going to use. There could be, it's interesting to talk about metrics, because when we say bits per request, that's kind of what everybody agrees is a good way to measure it. But if you can find some even more valuable way to measure efficiency, then that might make it an even more interesting problem. Because we're solving it in this frame. This is what the terms we use. But if you change those terms, it might open up a whole other problem to solve. So the first method for blind SQL injection, we're only going to talk about blind. So the first method is just to take whatever character you're trying to extract and try every possible character. So you go, is it an A, is it a B, is it a C, is it a D, and eventually you try to enumerate the entire ASCII table. If any of you are lost at some point, just stick up your hand. Okay? Okay, cool. Yes?
So but maybe for the new shows it that sounding bad, give an example, okay, you're trying to you found a SQL injection, you're trying to just see what's the database name.
Okay.
And explain it from there.
Okay, so let's say you're trying to let's say you're trying to extract someone's password, but all you can see from the database is true or false responses, right? So somehow you have to take a whole bunch of true and false responses, and you have to turn that into a representation of the password. The way you can do that is to say, let's say I don't know how I'm going to show this now, but let's say this is the password, right? The database is going to act like an oracle, and it's going to tell you whether your guess of each letter is right or wrong. You can't see any of these letters until you get a true response. So you're going to try to guess the first place letter, and you're going to go, is it an A? And it's going to say false. Is it a B? And it's going to say false. And you're going to try all these letters until you get the T, and you say, is it a T? And it goes true, then you know the first one's a T. And this will be reflected in the way the web application responds. So it'll show one page for true, and it'll show one page for false. The reason that happens, I'll give you a really practical example, is if you're writing a login form, and you need to look up whether a username and password pair exists in the database. Because usually that means that you're allowed to authenticate to the web application because you exist with this username and this password. So what happens is the application will, let's say, share the authenticated content for the web application, or it'll share the login page again because you're wrong. So whether it shows one of these two pages, you're actually inferring true or false responses from the database. So that's how that works. So you're going to try you're going to do the same thing for every single letter. You're going to try from A all the way up to H. You're going to try from A to E, from A to R, and then every time you hit the right letter, it'll give you a true response. And this means you could potentially have to enumerate worst case. Let's say the password is whatever character is 256 in the ASCII table, which I don't know now. You have to try all 256 possible characters for every single letter. And if there's n if there's n if the thing you're trying to extract is of length n, it means you could potentially do 256 to the power n. Is my math right? Right? Cool. You know math. So this is really, really bad. This is like literally the worst timing you could ever. I mean, there's probably no worse way to solve this problem than using this method. So if I had to draw a little picture of what it would look like, in terms of like trying to imagine how much it'll cost you, this is what it would look like. So this is the index of the character, and this is what you're trying to extract. Obviously, this says password, and this is the lookup table. So you're going to try A, it's going to be false, B, it's going to be false, C, it's going to be false, D, it's going to be false, and then eventually you're going to, somewhere in that sort of ellipsis, you're going to get to P, and it's going to be 1. And then you spent all these requests, which adds up the cost. So if you look at all these blocks with numbers in, and you add them up, that's a good representation of how much it cost you to look up that password. Is everybody sort of clear on how the naive method works? It's like the most straightforward method. You just try all the characters until one pops. And this is the good and bad. This isn't really an important slide because I'm pretty sure it's straightforward. It works. That's why it's good. It's parallelizable. You can have multiple threads looking up the same string, trying different characters. There's no your wrong or right guess for one character doesn't influence the wrong or right guess for the other character. So you can have one thread guessing one character, another thread guessing another one, another thread guessing the rest of them. So you can parallelize it, and that will probably make it faster. But parallelization is not really a good argument for Pro because that's a ubiquitous thing. It applies to almost every, all of the blind SQL injection methods. So it's not really that much of a win. It's like saying that this bread is good because you can put butter on the bread. That applies to all bread. So it doesn't matter. Yes, the base case is pretty good. You could have a string where you guess every single thing exactly right. That is a sub case of the solution, but it's like guesswork. You have to guess efficiently. That's what it depends on, and it's stupid. That's why it's bad.
It's really brute force to me.
Yes, yes. Trying to pro and con the brute force solution. Only Connor could come up with it, but it's dumb. So this is the next step people came up with to make it a little bit faster, and this is a pretty good big step because it's very hard to beat this time, even though it's a very simple idea. So this is divide and conquer, and the way this works is pretty clever. You're trying to extract information from an ordered table of elements, right? So there's it's ordered from 0 to 256. That's the ASCII table, right? And usually when you're trying to work with data that has some kind of ordering or partial ordering, in computer science terms, usually that means you can do divide and conquer. So if you're searching through data that's well ordered, you can binary search it, which is basically this. I'll explain that in a second. But let me show you the picture because it's a little hard to explain this in words. But what happens is, you know that the middle of the ASCII table, the middle-ish value is like 127, right? So you know that every single value that you're trying to extract is either bigger than 127 or smaller than 127, correct? Or it is 127. So you know that if it's smaller than 127, it can only exist from 0 to 127 if that value you're looking up is in that range. And you can actually repeat this step and weasel, like whittle down the range you're looking for by asking that question. So you basically take the character and you say, database, is this bigger than 127 or is it smaller than 127? But we skipped a step here. You actually ask a question before this. But anyway, you go, is it 127? Is it smaller or bigger? If it says yes, then you know you're working from, is it smaller? Sorry, I might have labeled this wrong. But if it's smaller, you know you're working from 64 to 127. If my math is right, you know it's in that range. And then you weasel it down more. You say, is it between 64 and 32? Is it bigger? Is it smaller? And you basically weasel it down. So I don't know if I'm explaining this correctly, but you take, let's say like, this is the ASCII table, these blocks here, right? So I have a character that's, let's say, this block. And I'm going to say, look, is it between, it's obviously between the beginning and the end. But I'm going to ask, is it the middle? Or is it this side of the middle? Is that side of the middle? It's going to tell me it's this side. right? So then I go, okay, I'm definitely working in this range. So I go to this part of the range, and I say, is it in the middle of this part of the range? Is it that side or is it this side? So it's going to tell me it's this side. And I go to this middle, and do the same thing. It's going to tell me it's this side, and eventually I'm going to know, is it this one? Is it either side of it? And I'll eventually get my right answer. And this is very, very clever because it actually reduces the amount of questions you need to ask, the amount of requests you need to send by log 2 of the length of your data that you're extracting. So on average, like if you're extracting n, it'll be log to the 2 of n of the length. So if you had to extract a character of length 1,000,000 characters, you would do 20 operations and you'd know exactly what character that was. Or you do 20 operations to look it up, basically. So that's a very clever method. The only problem is it can be a little complex. It takes a little bit more brain to script it out. Anybody who's tried to write binary search will tell you it's not the easiest thing to just whip out. You got to be aware of what you're doing. This is what the algorithm looks like. So, whether you respond to pictures or logic, kind of the same thing. So it says, if start minus n, this is the index that we're working with. If that's 0, if it's the same number, then there's no option. You have to be working with the answer you're looking for, right? Because it can't be between two numbers that are the same. That's impossible. Just return whatever's at the table position. This could be start or end. And then you say, if the letter you're trying to extract is bigger than, is on that side of the range, then return that part of the table. So work with that part of the table. If it's on the other side, return the other side of the table, and just repeat that recursively until you hit a case where there's no more table left, and you must be working with that. But there's one mistake in here, though. I think there's one mistake in that algorithm. It's got the this lecturer that I had always used to do this, but it's got the gist of the idea down. But the mistake is that it's not checking for if you're at the actual when you go either way in the question. It's not checking that you're at the right answer already before it asks a question. So that's a mistake. But besides that should work. Okay. So the advantage of this is it's much cooler to say you can divide and conquer than brute force. It's parallelizable, and the strong average is that it's 8 requests per byte because of the way it works. I'm not going to prove why it's that fast. But okay, so that's a really big improvement. But people have come up with some clever tricks. They decided that it's much easier to just work with the raw bit value of the value of what you're trying to extract than looking it up as a character on its own. So there are 8 bits in every character. Why not just try to extract those bits? They didn't realize, and the reason this took a while to come out was because people assume certain things about how types are treated in databases, but it turns out for databases like MySQL, it doesn't really care whether it's a number or string. You can make it treat anything as any data type. It's really, when you're talking about passing it through functions, it doesn't really have that many qualms about what you're working with. So for instance, this actually returns, it should be a number, according to our understanding, but the bin function in MySQL returns a string. So if it's a string, you can substring it. And if you can substring it, you can extract. So this is going to return the binary value of whatever the character is, right? It's going to be a bunch of ones and zeros. And then if you extract one character from the first position, then it's either going to be 1 or 0. And if you say, is it equal to 0, it'll say, yes, it's equal to 0, yes, it's equal to 1, or, yes, or no, it's not equal to 1. And you can then use that as a true and false response. So you're literally just extracting the bits in the actual character. And that means, what's good about that is, it will always be the 8 requests, because you're working directly with the bits. You're not searching through a table, you're not brute forcing anything. Every single character will always give you 8 bits. And there's a reason we like this method, because it makes it way more applicable in other areas. So that's bitwise extraction. And there's a lot of variants to this. So you can either use bit shifting, you can use ANDing. There's a whole spectrum of bitwise operations you can use besides just equal. So you can imagine if you're extracting a long bit string, you know that asking certain questions about what the value is once you shifted it a certain amount of bits left or shifted a certain amount of bits right, if you can ask questions about that number, then you can infer what number you're trying to extract, right? I'm not really going to explain too much about that. It's easy to imagine like where you're going if you try to, instead of using equals, you're going to use shifting left or right. Another reason why you'd want to do that is because a lot of WAF filters look for something equal to something, but they completely miss something bit shift something else. Because they didn't, for a time, most WAF filters had no idea that they were doing SQL injection. If you use these characters, so you didn't even have to use equals. You could just use and, which is a pretty safe character in most cases. Unless it's a post request, because then it could be HTML decimal encoding. So this is just this is a really old picture. Who can tell which Ubuntu version this is?
11.
Yeah. I think it's 11.
11.04, I think.
So from 9 to like 11 it was pretty much the same thing, and then 12 they were like spoke by Ubuntu. Yeah.
The Unity.
Gorgeous. This is before Unity. Much
No,
more OS.
all the way down to.
But anyway, so this is how it works. Like it's just showing you if I was extracting the first character of the username, then this is how I would do it. I would ask it, is the first bit of the so you go give me the user string, substring it, and then take the ASCII value of that, and then take the binary value of that, and then take the substring. And then the substring you take is from 1 to 1, and you ask if it's true. So it's asking, is it equal to 1? Yes, it's equal to 1. And then it takes the next character, is it equal to 1? Yes, it's equal to 1. Takes the third character, is it equal to 1? No, it's not, so you know it's a 0. So that's kind of how it works. You're basically extracting the binary value of the ASCII value of the first character of the username. It's a really long story, but yeah. So this is a really cool method. I think it's literally the fastest you can do it, but there's like some things that are not so good about this method. Basically, we all know that for a time when URL rewriting was not such a big trend, you had a lot of websites that had page ID equal to this, page ID equal to that. He knows when you see that, like 90% of the time it's SQL injection. You can try SQL injection with that. That's like a common trick. Oh, it's probably looking at the index. So that was a really big trend in web development, to have page IDs. Joomla is one good example. They do that all the time. It's terrible. But yeah. So what that means is you have a whole bunch of pages that correspond to numbers, right? And if there are 256 of them, it's a really good situation because you can ask the database to display a page that, in a way that represents an ASCII value of a number. So you can say, if the character I'm extracting is an A, give me page number 97. And you would know that if page 97, number 97 returns, what you're looking for is an A. And what that means is you've just sent one request and got an entire byte back from the database, which is incredibly fast. But the way you can make it simpler for yourself, obviously, is like you produce a hash of each page. But it's used, hopefully, the fact that you're extracting page 0 or page 256 is distinguishable using a hash function. So that's why it's called pre-computed hash method. Is that cool? Does everybody understand that? Pretty straightforward, and it's really fast. I think there's one or two tools that do this. I don't know if SQL Map does it. As far as I can see, they don't. They've kind of just, when this came out, they kind of stopped adding like new payloads to SQL Map, as far as I know. Because I would ask them questions about it, and then they'd be like, yes, and then it'd be like, you guys are lying, like it's not in the code. Because I've actually looked at it, and then I asked them, because I wouldn't ask them, and then like wait for them to lie to me. I checked it first.
Go in expecting they're going to lie to you.
Well, I'm paranoid. Yeah, so it's really fast. It's really clever. Well, I might be speaking under correction since this is being recorded. If SQL Map does use it, sorry I said that. As far as I can see, they don't. So yes, the good and bad is it's really, really fast. It's really simple. It's like just insanely clever because all you have to do is compute hashes and ask it what they ask. Basically, just say, please give me the page with the ASCII value of whatever I'm extracting. It's really, really clever. So I don't know. We'll talk about how you might make that either guessing a small amount of characters, or you've got to have a way to guess a whole bunch of characters. But the more characters you add to your table, the bigger the number, the index number is you have to extract. The more bits it's going to take up to extract that index number. So if you have potentially only 4 possible positions in your index table, you only need 2 bits. If you go more than 4, you're going to need 5, 6, 7, 8 bits to extract it. If you get to 8 bits, you might as well just extract the ASCII value itself. Is what they'll, like, it doesn't make sense using this. So that's what's dumb about it. Like, it's this.
So sorry, but where do you get the characters that you know are valid from?
Sorry?
Like those ABC or whatever, they have to be valid characters for that. So do you just put in like all the characters from the like ASCII table, or
whatever you think will be in your payload? That's that. I didn't come up with this method. I'm just explaining how it works. But this is kind of the idea. You have to like have this little collection of characters you're trying to guess. So you're going to say, in this collection, it's probably going to be what I'm trying to extract. But the reason I'm mentioning this method is not because it's brilliant in any way, but it's because I've applied it in a way that makes it pretty clever. This is how it works. So this is a data extracting lookup field. If you're looking up C, C will probably be, let's say, for instance, it'll be position 2, and it'll return this. So you'll extract that value, and you'll extract it in a series of true or false responses. And when the true or false responses come out in that pattern, you know that you're extracting index 2, so therefore it was a C, or 3 if you're coming from 0. But yes, the problem with the method is the more accurate you guess, the more accurate you can guess, the less efficient it becomes. And the reverse is also true. Basically, it means you need to be able to cleverly guess what you put in your table. And if you can cleverly guess what you put in your table, why not just guess what you're trying to extract? Does it make sense? There's actually a Black Hat talk. This method comes from Black Hat talk. I can show you. I'm not gonna. You guys should look it up. I'm just making trouble for myself. But yes, that's my argument. This is like how I analyze the method. I don't think it's that clever. But yes, this is some improvements that I've made. As far as I know, nobody else has really like tried to improve this method or published anything to try and improve it. So I'm gonna like claim that I came up with this until somebody proves me wrong. That's the way science works. So yes, we extract. So what about combining like bitwise extraction and the lookup table idea? And the way you do this is you only really need. So the aim of the game is again more bits per request. You want to fill more bits per request. So all we need to do this is we need four elements in our lookup table, and these 4 elements will apply to whatever you're trying to extract. And we're going to extract what I call bit prefixes, and we'll see how this works now. But the 4 possible values are all possible 2-bit values that you can extract. So it'll be 00, 01, 10, 11. And then what you can do, if your database is set up this way or the page is vulnerable in this way, is you can actually take the 4 different responses that we talked about, the 4 different kinds of extraction, blind, time-based, and error-based, and you can use each different response to map into one of those positions, right? So you could say, make this, just listen to what I'm saying exactly. If it's 00, make it true. If it's 01, make it false. Make that sleep and make that error. And what that means is, if you're trying to extract, if you're extracting 00, those 2 bits, the database will return a true response. If you're extracting 01, it'll return a false response. If you're extracting 10, it'll return a sleep. It'll sleep as a response. And you have to be able to obviously differentiate sleep and an error-based response. And what that means is you can actually then send 1 request and get 2 bits. And this is what the actual payload looks like. It's not important how this works. It's really just make sure that most of the time it'll cause a grouping key error because you're grouping on a key that might not be unique enough. But yeah, so you use this is for MySQL. It uses, and there's a equivalent function in MS SQL and the other DBMSs as far as I know. But use the field function. The field function returns the first occurrence of the in the table of the data you're giving it. And what I'm doing here is I'm concatenating 2 bits, and you'll see this is the binary value of the payload from position one one character in, and the binary value from position 2 1 character in, and then it basically takes the first 2 bits and looks it up in the table, and the table returns one of these responses: true, false, sleep, true, false, error, or sleep. And using that, you can actually extract 2 bits per request. Does that make sense to everybody? Cool. So yes, that's one good way to use the lookup table method, because you'll never have to play. You don't have to. It doesn't impose that you know anything about what you're extracting, except sorry.
I'm sorry. Like I know the stuff on this slide is new and is your technique, but like the previous ones that you're kind of improving on, are there any tools that actually make use of that?
Well, divide and conquer, I'm pretty sure SQL map guys know about that, because I can see it. There's like a little, I think it's called payloads.xml. If you look at the GitHub project for SQL map, that's in there. They have error-based in there. They have time-based, obviously. All the classic methods, but I've seen one tool for pre-computed hash, and I think this is the guy that actually came up with it, one of the first guys to publish about it. So he wrote a tool, and it's very, very fast. But I don't know of any tools that use this method, or any tools that use bin to position, or the original.
And bin to position is like MySQL specific?
No. So actually the first time I saw bin to position was a MySQL application of it. But I'm pretty sure, I need to check this, I'm pretty sure the other DBMSs like PostgreSQL and all the other cool things, they all have this kind of equivalent field method. And if they don't, you can emulate it using string matching and substringing. It's not that big a deal. You can write, this is basically just a convenient way to write an if statement. Or you can use regexes, whatever you want. So it should apply to all DBMSs as far as I know. So then, the other thing you can do with this is you can actually exploit time-based extraction a little bit more efficiently, but you have to work. In terms of requests, it's more efficient, but in terms of time, it might be not that efficient. So all I'm doing here is saying, like, if you're trying to extract if you can only use time-based, then you can actually have different waiting periods, and this probably won't be significant enough, but different waiting periods to indicate which bit pattern you're extracting. So it's a simple application for that method. So yeah, and these are some other ideas I'm working on, just in concept. This is actually like not a good instance of sort of the fusion dance to take, because this fusion didn't work, and I'm trying to propose an idea here of that is a fusion. But yes, so bin to position and pre-computed hash, basically the idea is if you can extract a whole byte. I don't like the idea of that byte only representing one character. So why not try to make that character that you're extracting represent more than one, or let's say 3 characters. And I think that bin to position can give you the power to infer more than one character from that byte. So that's basically that idea. I'm not going to say more than that because it's a very raw idea. But the other cool one is just abusing the way hash functions and cryptographic, the way encryption functions work. It's basically like a 3-dimensional mapping. So you have a key and a payload, and that'll output a certain cipher. And per key, there's different sets of ciphers per payload. So it kind of works like a 3-dimensional space, and you can potentially use that to extract information. So for instance, we know that if we use a certain key and a certain payload, that it'll be the stuff that it spits out is going to be very unique. That key into that payload. There's no way you're going to use one key for one payload and you can confuse it, or there'll be like subsets of the cipher space that clash. If that happens, then we're in huge trouble, because if you encrypt a message with your key and I encrypt with mine, we could potentially have with the same cipher, which like doesn't work. It doesn't work at all. So that's what I mean. It's a very strong, unique mapping that you can take advantage of. You can use a hash function if you want as well. If you can imagine making it simpler, you can actually append a key. But what I'm talking about here is, this is information you're trying to extract, and this is information you're trying to extract, and this is representation of it. So you could potentially make a cipher and extract the first or few bits or first character in the cipher and take that offline and crack it because you know what potentially what the cipher would be down to a few bit patterns. So you can pre-compute a whole bunch of bit patterns according to and encrypt them. So let's just say you're trying to extract a long bit pattern, right? You can chop that up into sections and use one chunk as a payload, as a plaintext for a cipher, and the other chunk as a key. That'll spit out a cipher that's unique to that pattern and that key, right? So what that means is you can identify that using very small bits of information in the cipher because it's very unique. If you change one bit of any of these two things, the entire bit pattern that the cipher produces will change. So that means that uniqueness is very good. It means you can potentially just use a few bits from that cipher to identify both the key and the plain text. So that's what we're talking about here. You use the database to compute that cipher, return a small bit of the cipher, and it'll tell you you can use that to infer a whole bunch. You can use it to infer these two pieces of information that produce the cipher. I hope that makes sense. So you don't have to extract the whole cipher to tell you what went into making it because it's so unique. You can just use a small part of it.
So you're saying like sort of A Jones, hashed, will obviously collide with XYZ, smiley face, bang, but obviously the probabilities of using
very small, very small. If it does, then you're either exploiting SQL injection or you're writing award-winning cryptography paper. Either one of the two things will happen. So that's just like the kind of idea I need to work out how I'm actually going to implement this. But as far as I can see, it's a pretty good idea. You guys can take me on it if you want. So yes, that's the end of the talk. Conclusion is don't call research academic. Tools are most of the time they're pretty stupid. Stupid in a way that they solve menial problems. Right? They're there to solve problems that are not very interesting. So don't rely on them too much. In my opinion, like for instance, there's like a whole infinite set of SQL injection vulnerabilities I can come up with that SQL map will never be able to exploit because it's a simple tool, and you'll never be able to exploit them if you can only exploit them using SQL map. So don't rely too much on tools. There is some art to exploiting things that there exist tools for. It's kind of what I wanted to talk about. Because nobody would talk about SQL injection anymore. The argument would usually end with, why not just use SQL map? That's kind of the point. And the other argument is like, a computer science degree is not completely useless when you're a pen tester. Yeah. That's it for me.
Just for most other things.
Yes. Picking up chicks? No. It's almost negative.
I thought they liked the algorithms.
Sorry?
I thought they liked the algorithms.
Yeah, that was a lie actually. I've never once walked in the bar and told the chick like I know deep sort, and that's never gone anywhere. She didn't go like, oh really? Let's go sleep together. Like, never anything like that. Yeah.
So, have you, with work, have you ever dealt with NoSQL kind of injections?
Oh, well, you mean like NoSQL databases?
Yeah. Graph databases.
I've never encountered that. Not that like these big clients that seem to hate like Apache projects, but but no, I've never had to. I've read about some of the NoSQL injection techniques. I don't remember much of what I read, but I should probably look into it. That's probably what you want to tell me.
No, like I've also just been reading about it. And
but it's not that prevalent yet. Like, I mean, NoSQL databases sort of, I think, came out because people were so afraid of SQL injection. They were like, if we produce NoSQL databases, maybe it means there's NoSQL injection.
What about the SQL syntax NoSQL databases?
Well, you're asking me like crazy stuff now.
Yeah, no, like the Sandra. I mean, the interface is basically a SQL string, but it's a NoSQL database.
I've never heard of that before. I probably have to look it up.
Irresponse also like that's good SQL.
Again, like that's the first time I hear this word ever.
But Mongo, I'm sure you could inject.
Dus ik heb al zo'n twee keer MongoDB injection gehad. Eén keer kon exploit, maar it's going to be very prevalent, I think. Because some people think, oh, it's no SQL, there can't be any SQL injection.
But there has been research before. Like, I mean, there's been proper papers written about this. Like,
yeah.
But it's obviously this is like JSON driven, right? If I can remember properly, like the return the results as JSON.
There's wildcards and
Yeah.
predicates.
So I think they go on the basis that you can abuse the fact that everything is sort of string driven. So you can inject like evaluations that return or that confuse input with the boundaries of that confuse the boundaries of the output. So imagine you inject like braces, and if it returns a JSON string, then you can actually make the application return your input as output, as valid constructors for the output. So let's say it returns like you inject something and it returns a valid user, but the braces and all the funny things in your input makes it so that the output is crafted to represent the admin user. For instance, like you could override fields in the JSON array that change the way the output is interpreted.
I suppose the other thing is also that, especially if you take one Elasticsearch, it's kind of NoSQL, but there's also NoSQL, but not. If you take something like that, is that the query that you make in terms of searching for things is very structured, but the sort of data that you can put in there isn't very structured. So you can put asterisks and all kinds of funny things in there as a search.
Yeah, so and again, that's kind of interesting because the sort of basis of SQL injection is that you're injecting things that confuse the way the DBMS interprets it. But when it comes to things like that, you can inject things that confuse the way the application interprets it. Because it's like the language is a lot less, like you said, there's no sort of constant form to it, no constant data type to it. So the application could actually be confusing to how it's displaying it. Yeah.
You see the remote code execution stuff for Elasticsearch and stuff like that. That's pretty cool. Like, basically, I do with what you say, like, it's not really structured like what you can put in there, you can put in anything, but there's actually a meta-split module for that. It's quite, like on that topic.
It's like last year.
Yeah, middle of last year, I think. And the attack surface for Elasticsearch gets a lot bigger because a lot more developers are going to use it. At the moment, it's usually just used like in operations context. But
are there modules you can write for Elasticsearch?
Yeah, well, there's like APIs now that you can kind of, for example, a lot of people are using it in their search engines and sites. And then it's always used like in a SQL database. So GitHub uses it for their search engine.
Which is why their search functions are terrible. It's terrible.
So a lot of people, what they use Elasticsearch for, like I said, they use it basically as an index to the database. So they use the database for things like sort of physical long-term stories, and then as they put things in the database, they put it in Elasticsearch as well. Okay. And then to get the data out quickly in terms of like a user running a query, they just put it in Elasticsearch. But the point being is that the data is mirrored in Elasticsearch. Anything that you want, you can get everything out of Elasticsearch. And because, like you said, the area of attack can be bigger with Elasticsearch, because sometimes the things is that
maybe you don't even need to attack the database to get what's in the database.
Yeah.
And then, like, not just finding the SQL injections, do you ever actually deal with helping the client fix it or looking at what they did wrong?
Well,
because, like, you have the whole writing pure SQL in the application versus the ORM being either custom or
so what we do is we usually just write up recommendations for them. As far as I know, that's about all we do. And I think we do that because it's kind of like an independence issue to be the guy who tell, hey, do you have you heard about what happened to Enron? So if you're the guy that like tells people how to fix things and fixes it for them, like people don't really like that in certain fields, especially risk consulting, because in the past there's been a lot of abuse. So as far as I know, the Enron story is like this company had the same guys giving them advisory and auditing them. So they could be like, just tell them that we're doing everything right and produce the reports to say we're good, because it was the same entity, and that's why they got away with so much fraud. Eventually people found out, and by then it was already too late. They've gotten away with a lot of fraud.
But you get what I'm saying, like these days everyone uses some kind of ORM. They don't even write your own SQL anymore, but you do find that some developer just...
Yeah, there's always, and it comes down to like pressure, you know, like you have a deadline, you have to push out something that works really quickly. So it's not, I mean, it's not really, I always say like it's not security faults, not the fault of the developer, functional faults are the developer faults. Security faults are the problem of people that don't invest in security. So just like I'm not gonna, like I'll never be able to keep up with all the trends in development, all the new tech that's coming out, all the new stuff that the plugins are adding to Eclipse, the repository kind of technology that's coming out. I'll never be able to keep up with that. It's not my job. And you can't expect developers to keep up with Black Hat talks. There's like literally a conference for every day, new bugs coming out. NVD is like flooded with CVEs every single day. Like how the hell are you going to keep up with both those things? It's impossible. So you've got to keep developers focused on functional things, and you've got to make sure there's somebody to make sure they're doing it securely. So yeah. Can I stop talking now?
Have you ever like seen like any weird databases like jobs? Sorry, I'm asking you random questions, but like.
Yeah, I'll tell you all the clients I work for and all the plugs I find.
No, but I mean, have you ever seen like, okay, like,
on
Is that the next slide?
have you ever seen like very weird databases? Like, for example, I've once seen a database that a company actually wrote for themselves, and then another one, I saw somebody use some, I can't remember the name now, Apache something, but it's a database, but nobody really uses it. So, like tools like SQL Map, we could obviously not exploit it,
Yeah.
to do it manually and stuff. But the funny thing is, it wasn't really, it doesn't have like stuff to do delays, whatever. But yeah, I just thought, is there any weird kind of?
I've never seen anything too weird. Luckily, like my clients, because of I active, they're usually have more of the bigger clients.
Yeah.
So the bigger businesses, the less they'll invest in like really custom solutions.
Yeah.
You know, so I luckily in the time I've been with, in the time I've been doing penetration testing, I haven't seen database technology that was too unique. I've definitely seen things that I didn't know about there, but that's just because I was inexperienced. But I've never seen something that's like really unique that almost nobody uses in terms of databases yet. But it would be really interesting because then immediately, like, I would be like, forget SQL injection. Let's try like buffer overflows. Let's try like type confusion stuff. Because nobody would be testing this thing. Like it's like 0-day city. Like I could try things that nobody's ever tried with DBMS before. So that would be pretty exciting. But if you're hitting like MySQL, like version 6 or whatever, I don't even know what's out yet, then there's very little chance you're going to find a buffer overflow. Because I'm sure there's like tons of there's like thousands of people fuzzing like MySQL.
Well, the thing with
that's an assumption you make.
As well is they do not really publish the issues that they find.
MySQL.
They say they fixed this, they've
but that's
fixed
why,
everything,
yeah,
but they do not say what they fixed.
But that's another area of sort of like exploit research is to look through those commit changes, look at what they fixed, and then you could infer like a bug from that. Because a lot of people, sometimes do that with really big popular products like browsers. So they'll go like, oh, why did you fix this and not really label it, or like why was this fixed? And sometimes you can tell that that actually caused a bug, but they didn't want to make a noise about it. And then you can publish an exploit for that, affecting the previous versions. Because not everybody keeps their browsers up to date, let's be honest. Yeah. So that's another awesome area of research.
Google, I think, released BinDiff free now, plugin for IDA. You can actually do binary diffs, which actually shows you the code execution differences.
Nice.
You can actually infer from what it did there. You can patch that up.
Nice. That's really cool. I don't do a lot of like low-level bug hunting, to be honest, but I know that the Google Chrome team, like, they have pretty big rig set up for fuzzing Chrome. Like, they literally, you can imagine, like, Google has literally some of the biggest cloud storage available, more than most people do. Like, they outrank the NSA in terms of what they can store. and that's a big job. So they've got like this cloud-based platform called Clusterfuzz, which I know we can all imagine what term that comes from. But yes, so they have all these. It basically like collects a whole bunch of HTML, PDF, and stuff, and pushes it through like a sample generation like thingy. So all it does is just flip bits, and then little scripts they write according to how they want to flip the bits, and they shove that through Clusterfuzz, and it hits like a test compiled version of Chrome. But it's really fast, to the point that nowadays finding a bug in Chrome is literally just a rat race to beat whoever's manning like Clusterfuzz at the moment. I think the guy's name was Inferno. There's a talk you guys should watch about this. This guy's name is Inferno, and I think he works at Google. But basically, Google Chrome bugs is just beating Inferno to report. If you can beat Inferno to beat Inferno to reporting, then you get a bug in Chrome. If you can't beat him, then forget about it. Like even if you're good at finding bugs, that's the other part of the competition, is beating that guy to report.
So do you have to have hardware equivalent to that?
There's a way you can do it by being original, so you can test in ways that people aren't testing. They're just making sure that all the things, all the trivial things that might slip through, don't slip through to the public, because they're very easily exploited. So they're making sure that if you do find a bug, it's got to be amazing. You know, if somebody else without this infrastructure finds it, it's got to be an amazing bug that really takes a lot of brain to find. But no, it's not impossible to beat them. You could just beat them with originality. So that's always the other avenue. Like a couple of years ago, nobody would be fuzzing Favicon images, but one guy actually found a low code execution bug by fuzzing a Favicon image, which nobody would have tried, because what the hell, it's like the oldest image format on earth. But he won the game, because nobody else was doing it. So, yeah. I should give you guys a talk. I'm talking like about this Inferno guy. I heard about him from a talk that somebody else was doing, who's really, really good at browser fuzzing. I think it's one of the guys that wrote Redamza. I don't know if you guys know what that is, but it's basically like a little test case generator for fuzzing, and you basically like shove in some bits and you tell it how to flip the bits, how to mutate it, and pushes it out. It's just one of the really good, that's all it does really. You decide where the input goes and what kind of input you give it, but it's one of the really, really good tools for fuzzing. You can apply it to anything, because all it does is flip bits. You can even, there's even like Burp plugins that people use to push samples out for Intruder. So you plug in Redamza, you give it like strings, you plug in Redamza and it pushes out payloads for Intruder and hammers it out the web application. So it's a statistically, like, I mean, you're getting statistically the widest range of inputs that way. Cool. How did we get from browsers, from SQL injection to browsers?
Questions you can ask the person.
Cool.
Thanks.